Doing section 4.2, example 1. So hopefully you've read about the product rule in the book and then the top of the worksheet here. So for example 1, again this is section 4.2, we have a product given for our function 4x minus 3, 2x squared plus 1. So of course we could just take the derivative of this using the power rule. We could multiply this out, do FOIL on it, and then just use the power rule. But the point here is that we want to practice the product rule. So the best way I think to do this is just to identify which function is which in the product rule. So at the top of the page there for 4.2 you see we identify u and v, the u function and the v function. Let's just call the u one first. So this is u of x, and then this is v of x. And then we just want to use that formula that we see there for the product rule. So it says f prime of x is equal to u of x, v prime of x, plus v of x, u prime of x. Sorry if that cut off there, but it's the product rule that's up there on the top of the page. So basically, we're just going to plug stuff into that formula now. To take the derivative of this thing, f of x is equal to u of x, so that's this function, 4x minus 3, multiplied by v prime of x, so that's the derivative of this function. We can use that using the power rule. That's 4x. Remember the derivative of 1 is 0. And then plus v of x, so now that's this function, just unchanged, 2x squared plus 1, multiplied by u prime of x, so that's the derivative of this one, so that's 4. And then of course we can simplify this, and if you wanted to multiply this out using FOIL, take the derivative using the power rule, of course you'd find you'd get the same answer here. So 16x squared minus 12x, and then if I distribute the 4 here, plus 8x squared plus 4, and then we can combine our like terms. 16 plus 8 is 24x squared minus 12x, and then plus 4 is the only constant. Okay, so there's our derivative using the product rule. Let's do the same for part B. So here we've got another product, which again we could, if we wanted to, just use the FOIL and take the derivative using the power rule, but the point here again is that we want to practice using the product rule. I'm going to go ahead and just write this square root as x to the 1/2 power, as we should do with all radicals when we're trying to take their derivatives. So let's just jump right in and use the product rule here. So again, if I identify that first function as the u one and the second one as the v, u of x first, I just copy it, so I get 2x minus 3, multiplied by v prime of x, so that's the derivative of this, that's 1/2 x to the negative 1/2, derivative of 1 is 0, plus v of x, so in this case v of x is the second one, so that's x to the 1/2 plus 1, multiplied by u prime of x, so u prime is the derivative of the first one, that's just going to be 2. And then of course we can simplify this. Let's go ahead and distribute this to here. The 1/2 and the 2 are going to cancel. X to the first power, x to the negative 1/2 power, that's going to give us x to the positive 1/2. Remember that when you have the same base raised to different powers and you multiply them, you add the powers, so that's 1 minus 1/2, gives us 1/2. And then if I distribute it to the second term, I get 3/2 x, and then that's just negative 1/2 again. Plus, then I'll distribute the 2 here, I get 2x to the 1/2. Distribute it there, I get 2. And then I check, do I have any like terms? And it seems that I do. I've got a 1/2 power here and here, so I can write this as 3x to the 1/2. And then that's the only like terms I have, so I'll just leave the rest of it as it is. And then plus 2. And again, if you wanted to write this without fractional exponents, you could write it as 3 root x. And then for that one, you could write it as minus 3 over 2 root x. Again, it's a negative exponent, so it's in the denominator, and then plus 2. Okay, so there's example 1, section 4.2.